This video is about leaving groups. When we're doing a substitution or elimination reaction, our first step is going to be determining whether or not we have a good leaving group. So, to determine this, we need to look at the leaving group's stability and its base strength. To determine its stability, we need to look at its Lewis structure, and for its base strength, we want to make sure that it is a weak base, because if it's a strong base, it's not going to be a good leaving group. So, we'll move over here with Ri, and I is going to be our leaving group. So when it leaves, it's going to take the electrons from this bond, and we're going to form I-. You can see here, as I'm drawing these in, we're going to have 8 electrons around it. So it's going to be a stable Lewis structure, and it has a conjugate acid of Hi, which is strong. So that means this I- is a weak base, and then this is going to be a good leaving group. So we'll move down here to bromine, exactly the same thing. Takes the electrons, has a stable Lewis structure, and it has a strong conjugate acid. So this is going to be a good leaving group because this is a weak base. Moving down here to chlorine, it's going to take the electrons from this bond. We're going to have a stable structure with a strong acid as its conjugate acid. So this is a weak base, and this is going to be a good leaving group. Now, we'll move over here to the alcohol. So as this leaves, the OH is going to take the electrons from the bond, and we're going to form OH-. Now, we have a stable structure, but its conjugate acid is water, which has a pKa value of 15.7. So this is a weak acid, so that means that OH- is a strong base, and then OH with the carbon is going to be a bad leaving group. So this is not going to work. So if we have a protonated alcohol, as this leaves, you can see initially we have a positive charge, so we're going to make a neutral molecule here, which is water. So if it's a neutral molecule, it can't be a strong base. We'll draw it out anyway. We'll draw out the conjugate acid, which is going to be H3O with a positive charge. And this is a strong acid, so that means this is a weak base. That means this is going to be a good leaving group here. So we'll go to hydrogen down here. We're going to draw our electrons going to the hydrogen. So we're going to make H-, which is called hydride ion. Now, its conjugate acid is H2, which we know has a pKa value of 35. So this is going to be a weak acid, which means this is a strong base, and this is a bad leaving group. So we'll move on here to methyl group, which when it leaves is going to be CH3-, which has a conjugate acid of CH4, or methane, which has a pKa value of 50. So that means this is a really weak acid. So this is going to be a strong base, and then this is going to be a bad leaving group. Now here we have an amine. When this leaves, again, it takes the electrons from the bond. We're going to make NH2-, which is a stable structure, but its conjugate acid is ammonia. Which has a pKa value of 38. So that means that this is a weak acid, this is going to be a strong base, and then this is going to be a bad leaving group. So, likewise, when we had the protonated alcohol earlier, if we start with a positive charge on the nitrogen, like if it has 3 R groups attached, when it leaves, it's going to be a neutral molecule. These electrons here. So it is going to be a good leaving group because this is not going to be a strong base. Next, we're going to talk about a special class of leaving groups called the sulfonates. Now, these are the conjugate bases of sulfonic acids, which are derivatives of sulfuric acid, which we know is a strong acid. So we'll start over here with this structure. And over here, we can see we have a methyl group coming off of this sulfur atom. And this is our mesylate, and the me comes from this methyl group. Over here, we have the trifluoromethyl instead of the 3 hydrogens. So this is our triflate, and the trifluo part comes from the trifluoromethyl. Now, moving on to our last one, we have a tosylate, which has a toluene-like group coming off of this sulfur atom. And one thing that we need to consider as part of the leaving group is when it takes the electrons here, we're going to form a negative charge. And this negative charge can be delocalized to these other oxygen atoms. So you can see here, if these electrons move, we're going to form a new double bond, and then these electrons are going to come up here, or they could come down here, and the negative charge will move. So this adds extra resonance stability, which gives for an outstanding leaving group.